Hello everybody. In this video we're going to cover radians as a unit of measurements. If you have this printed out, that's great. If you don't, you can still follow along. For those of you who have it printed out, you can follow along with what I'm writing here. Okay, so let's get started. This is success criteria. We'll answer this at the very end to see if we understood everything. Evaluate sine pi over 3. This pi over 3 is a radian. We're usually used to seeing like sine 30 degrees or some angle inside here, but this one has radians. Okay, and we're going to figure out what that is. So let's start with the definitions. So first, let's start with what degrees are. Degrees are a unit of measurement, right? To measure an angle, with 360 being a full rotation. So if we take this diagram and we start here, a full rotation would be this, and we call this 360 degrees, or we measure this as 360 degrees. I can estimate the angle between this axis and this arrow here. Let's say it's 60 degrees. So degrees are a pretty useful unit of measurement to measure angles. But there's another unit of measurement that we can use, and it's called radians. So radians is a measurement of angles with 2 pi being a full rotation. As you can see, the definition is very similar to degrees. It just has 2 pi instead of 360. So as you would guess, the angle for a whole rotation in radians is 2 pi. Okay. So in the previous definition, we said that this here, this arrow, the angle between this arrow and this axis is 60 degrees. Right? And you know that 60 degrees is about 1/6 of 360. So what do you think this would be in radians? It's going to be exactly 1/6 of 2 pi, right? So that's 2 pi over 6, which is pi over 3. So this can be written as pi over 3 rad. Okay, there will be more details on how to convert from degrees to radians later on. Before I show you how to convert from degrees to radians, I just wanted to give you a little bit of more information about radians. So yeah, radians are another unit of measurement that we can use, and it's useful in calculus because it makes it more convenient. But it also has other properties. So for instance, let's consider a circle with radius r. So radius is the distance from the center to the outside of the circle here. Okay, so that's r. The circumference, if you remember back from grade school, would be, the formula would be 2 pi r, or pi times diameter. And then here it asks you to calculate the arc length of 1 radian. So since 2 pi is 1 full rotation, the arc length of 1 radian must be the circumference, 2 pi r, divided by 2 pi, right? And this equals r, the radius. So what this means is that if you take a radius, if you take a 1 radian measure and you find the arc length of that radian measure, this arc length is equal to exactly the radius of that circle. Okay. So the conclusion is that 1 radian is equal to the arc length of 1 radian the arc length of 1 radian is equal to the radius of the circle. So that's one significance of the radian measure. Okay, so let's figure out how to convert from degrees to radians more formally. So let's say we have 360 degrees. Oh, we already know that this is 2 pi radians. That's what the definition is, right? One full rotation being 2 pi, and one full rotation in degrees being 360 degrees. So 360 degrees is equal to 2 pi. Well, to do this more formally, we can take the degrees, 360, and multiply by its conversion, which is 2 pi rad over 360 degrees, which is equal to 2 pi, because these cancel. So this conversion should be a little familiar. So as an example, let's say we want to convert 1 meter to centimeters. The way we convert this is we take 1 meter and we multiply by its conversion, which is 100 centimeters divided by 1 meter. Because this is equivalent, 100 centimeters and 1 meter is equivalent. And then we get 100 centimeters as the answer. So yeah, this doesn't necessarily have to be 2 pi over 360, as long as the numerator and denominator is equivalent. So for instance, pi over 180 would work as well. So let's use pi over 180 for number 2. So we have 240 degrees. You multiply by pi over 180 instead. Okay, this would be equal to 24 pi over 18, which is equal to 8 pi over 6, which is equal to, I'm just simplifying here. So it's 4 pi over 3. Okay. When you multiply and convert degrees to radians, you want to make sure that you leave the pi there. You don't want to multiply it out. Okay, it makes things a lot simpler. Let's see, 30 degrees, multiply that by pi over 180. Or let's go back to 2 pi over 360. I'm just showing you that we can interchange between the two. It doesn't really matter. Okay. This would be equal to 1 pi over 6. Yeah, if you multiply it out and simplify the fraction, you should get pi over 6. Yeah, and the units is rad. Okay. So radians to degrees, you pretty much follow the same procedure. Pi over 6 times its conversion, which is 360 degrees over 2 pi. This time we want the degrees in the numerator because that's what we want. That's what we want to convert to. So this, the pi's cancel, and you're left with 360 degrees over 12, which is equal to 30 degrees. Okay. Let's do the next example. 3 pi over 7. I'm going to multiply that by, again, you can use 180 over pi instead. The pi's cancel, and then you end up with 540 degrees over 7, which I don't think I could simplify. And the last one, you can pause the video, try it yourself, and compare your answer with mine. So this 5 pi over 2 multiplied by 180 over pi, which should equal to 450 degrees. Okay. that's pretty much it for this lesson. I just wanted to show you how to convert from degrees to radians and then radians to degrees, and also tell you what exactly radians are. So let's summarize. Degrees to radians conversion. Let's say you have degrees like so, x degrees. You have to multiply that by its conversion, which is 2 pi over 360 degrees, which will give you your answer in radians. As you can see, I have the 2 pi in the numerator, 2 pi in the numerator, because that's what I want to convert to. And then let's take a look at radians to degrees. So let's say you have y radians, and you're going to convert to degrees, then you multiply by 360 degrees over pi, 2 pi radians, which is equal to something degrees. And again, you can multiply this by 180 over pi if you want, same thing. And then you would get the same answer. Here you can multiply by pi over 180 instead, and then you should get the same answer. Okay, so again, to summarize, radians are another way to measure angles, and it's more convenient for us later on, especially in calculus. There's another significance to radians. The arc length of 1 radian is equal to the radius of the circle. You can convert from degrees to radians and radians to degrees using these conversion methods here. And that's about it. So for next class, please complete the worksheet that I have attached. And that worksheet will also be on Google Classroom. And that's about it. Thanks.